At the end of each chapter is the chapter review. That's the same length as the test, the same format as the test, the same order as the test, and most of the time the questions are in the same order that the text was written. So questions 1 and 2 came off of page 1. Questions 3, 4, 5, 6, and 7 come off of page 2. Questions 8 and 9 and 10 come out of page 5. Question 11 came out of page 5. Excuse me. Question 12 came from page 7. Question 13 came from page 5. Question 14 came from page 7. 15 and 16 came from page 8. Yep, that's right. And number 17 came from page 11. 18, 19 came from page 13. 19 came from 13 and 15 combined, and number 20 came from page 15. So it's written in the order that the textbook was written. Okay? So here we go. I'm going to go through these. I'll go through these a little bit quickly because of the time it takes to actually do this. First thing we ask is, what is the operation? Second thing, what is the rule for that? The rules for addition and subtraction. Data subtract, the names have to be the same. In algebra we call them, are these like terms? Yes, the name of the first term is xy. Second term, when you add or subtract, the name stays the same. Are we supposed to put an x square, y square?
No.
Because if we put the squares, the name changed. So we actually say the rule, and there's no way we can mess up. The name stays the same. We combine like terms using sign rules. We have to think sign rules from now on. What is the sign of the 5? What is the sign of the 7? Positive. When you add or subtract with the same sign, you add and take the common sign 12. No, my test you don't have to write positive there. Just do it in your brain. Because if we don't get used to that. So what are we really doing? We simplified the expression by combining like terms, and we combine like terms using sign rules. Okay? The vocabulary is very important to keep us from making mistakes. All right, number 2, this operation is subtraction. Rules, to add or subtract, the names have to be the same. In algebra we call them like terms. The name of the first term is xz. The name of the second term, xy. Are the names the same? No. So can we subtract? No. So we say that this expression is already in simplest form. Understand that? How else could you have written that answer? Just copy it back down. 3xz minus 2xy, right? Which is basically saying it was already in simplest form. Okay? Any questions on number 1 and 2? All right, number 3. Number 3, we want to talk about the rules from page 2. To simplify an expression, you put like terms together and combine like terms. That's what it says. And then to carry or bar, you ask the question, how many of these does it take to make one of those? So we're going to clear the screen. going to add inches to inches. 9 inches plus 8 inches is 17 inches. When you add, do you carry or borrow? You carry if you have enough. To carry or borrow, you ask the question, how many of these does it take to make one of those? So our question now is, how many inches does it take to make one of those feet? How many inches does it take to make a foot? And the answer is 12. So what do? We subtract out the 12 inches that it takes to make a foot, and we carry that over as 1 foot. Everybody take time to look at that, soak it in. Any questions? So we actually do the subtraction. 17 inches minus 12 inches is 5 inches. Now we go to the next column over feet, and we combine our feet. We have 2 feet plus 1 feet is 3 feet plus 2 feet is 5 feet. And then we have to ask the question, how many of these does it take to make one of those? How many of these little what? Feet does it take to make 1 yard? How many feet equal 1 yard? And the answer is 3. So what do we do with that? Subtract it out. We take out 3 feet. That leaves us with 2 feet. And we carry the 3 feet over as 1 yard. Understand that? So now we add up our yards. 1 yard plus 6 yards is 7 yards plus 4 yards is 11 yards. And then we ask the question, how many of these does it take to make one of those? How many yards does it take to make a mile? How many yards is equal to 1 mile? 1,760. Do we have enough? No, so we just bring it down. 11 yards, 2 feet, 5 inches. Any questions on number 3? Okay. Number 4. Number 4, to add or subtract, the names have to be the same. In algebra, we call them. To simplify an expression, we line up our like terms. We put our like terms together, and then we combine those like terms, right? So we're going to put our minutes with minutes and hours with hours. When you subtract, do you carry or borrow? You borrow. To carry or borrow, you ask the question, how many of these does it take to make one of those? So we've got 38 minutes and we're trying to take away 49 minutes. Can you take away 49 if you've only got 38? No, so we need some more minutes. Where are we going to go to get them? Hours. So we borrow an hour. That knocks us down to 16 hours. And we ask a question. The question is, how many of these does it take to make one of those? How many minutes is equal to 1 hour? And the answer is 60. So what do we do with those 60 minutes we borrowed? We add it to the 38 we already had, which gives us 98 minutes. Understand that? Now we can subtract 98 of those minus 49 of those leaves 49 of those little minutes. 16 hours minus 8 hours is 8 hours, and so we get 8 hours and 49 minutes. Any questions on number 4? Yes, sir.
When you got 98, 49 minutes, could we, since 8 will go to 9, can you take away 9 and make 8 18?
Yes. So the question is, when you actually get to the part where you're doing 98 minutes and you're trying to take away 49 minutes, when you're actually doing that subtraction, can you do the normal old carry bar thing? Kind of forget the minutes are there for a second. You can't take 9 away from 8, so you bar from the 9, makes it a 8. You barred 1, 10, which is how many ones? 10. 10 ones added to the 8 ones makes 18, so it's kind of like you put a 1, but we know why. We barred 10, 1, which is 10. So 18 of those minus 9 of those is 9 of those, and 8 minus 4 is 4. And then we put the name back on. Right. And, yeah, you can go shink and stick a 1, but I want you to know why. We borrowed 1, 10. Whoops, that's weird. 1, 10. And we wanted to know how many ones that is. And so the 1, 10 that we borrowed was equal to 10 ones. And we added the 10 to the 8, which made us have 18. There's the logic. Yep. All right, any questions on the first 4? Okay. Number 5. Number 5, what's the operation? Subtraction. To add or subtract, what has to be true? Names have to be the same. In algebra, we call them. To simplify an expression, we put our like terms together and combine like terms. Why do I say that? Because there's going to be students who forget when are you supposed to make them improper and when do you not make them improper. And so I wrote it out the way you think it. When you add, you line up your like terms. There's not a need to make them improper. When you multiply the numbers and you multiply the names. We got to make them improper to see the numbers and the names, right? So there's some basic common sense reasoning as to why we do one or the other. Now, we're subtracting. When you subtract, do you carry or borrow? You borrow. We have 3 of those little 17ths, and we're wanting to take away 9. Can you take away 9 if you only have 3? No. You do not go shink and stick a 1 and make it a 13. That's what people that do it wrong do. We have to ask our question and run our drill, correct? Our question is, how many of these does it take to make one of those? Well, what things are we talking about? How many 17ths makes a whole? How many 17ths is equal to 1 whole? And the answer is 17. What do we do with those? We add them to what we already had. And now we have 20 of those little 17ths. See how that looks just like the one that had the minutes and stuff? We needed more minutes. We borrowed an hour, which is so many minutes. We added it on. So now 20 of those little 17ths minus 9 of those little 17ths leaves 11 of those little 17ths. We actually borrowed from the 8. That makes it a 7. We borrowed 1 whole, turned it into 17 17ths. Leaves us with 7 minus 3 is 4 and 11 17ths. Any questions on number 5? Yes.
If you did make them all improper fractions, would you still get the same?
So the question is, if you made these improper, would you still get the same answer? And the answer is yes. And later I will do something to explain that, but not on this review. So when I get off the air, I'll show you something. All right. It is okay to make them improper and add and then convert them back. Okay? Number 5. Number 5, the operation is addition. To add or subtract, the names have to be the same. In algebra, we call them, with fractions, we say that we need a, do those have a common denominator? Yes, so what do? We line up our like terms, and then we combine those like terms. So when you add, do you carry or borrow?
Carry.
When you add, you carry. So we have 3 of those little sevenths plus 6 of those little sevenths makes 9 of those little sevenths. Now we have 2 choices, and the first way we're going to do it is the way we did our units of measure, right? We're going to ask a question. How many of these does it take to make one of those? How many sevenths does it take to make one whole? And the answer is 7. Now when we found out how many it took and we're carrying, what did we do with that? We subtracted it out. We subtracted out the 12 inches. We subtracted out the 3 feet to make a yard. We subtract out the 7 sevenths, which leaves us with 2 sevenths, and we carry that over as one whole. That's doing it exactly like we did the unit of measure ones. And then we add 5 holes plus 1 hole is 6 holes plus 2 holes is 8 holes and 2 sevenths more. Now we do know that 9 sevenths is 9 divided by 7. It'll go one time, you get 7 with 2 left over. You put your remainder 2 over your divisor 7, and we get 1 and 2 sevenths. So we could do that, bring the 2 sevenths down, and carry the 1. So there's 2 ways of understanding how to go from the 9 sevenths to carry. This way models our units of measure approach. This way is using what the fraction actually says. It says 9 divided by 7. Any questions on the first 6? Okay. Number 7, the operation is addition. There's more than one, but it doesn't matter. There was a whole bunch on the last ones, right? This many hours plus this many minutes plus this many hours plus this many minutes we talked about. There's more than one addition there, although you just saw one. To add or subtract, what has to be true? Names have to be the same. In algebra, we call them like terms. So we're going to put our like terms together, which means we could rewrite this as 5xy plus 7xy plus 2 square root of 7 plus negative 5 square root of 7 using the commutative property of equality. That's what it says on page 2. On page 2 it says, to simplify an expression, we're going to put our like terms together, and in parentheses it has a little commutative property, and then it says, and then combine like terms. When we put our inches with our inches and feet with our feet, we realigned using commutative. I don't make you show this step, but that's really what's happening behind the scenes. So we've allowed you to just underline your like terms and then combine your like terms using what? Sign rules. Now when we combine our xy's, what's the name going to end up being? xy, because when you add or subtract, the name stays the same. What's the sign of the 5? Positive, and it's not a 7.5 because that's the number of the problem, it's just a 5. And what is the sign of this xy? Positive. When you add or subtract, same sign you add and take the common sign, so we have a positive 12xy. We're going to add our square root of 7s. When you add or subtract, the name stays the same, so the name stays square root of 7. We check our signs. The sign of the 2 is positive. The sign of the 5 is negative. When you add or subtract with different signs, you subtract and take the larger. What was there more of? Negatives. So it's going to be a negative 3. To show that it's negative, we put a minus, because we learned with sign rules on page 18, minus 3 means negative 3. If the sign of the 3 was positive, we would have put a plus. So we did what? We simplified the expression by combining like terms, and we combined like terms using sign rules. Okay? There's the language of what we're doing. Any questions so far? Number 8. Number 8, the operation is multiplication. Common sense rules. When you multiply or divide, the names do not have to be the same. They do not have to be like terms. Are they like terms? No. Do they have to be? No. Do you put simplest form? No. Because they don't have to be like terms to multiply. Well, how do you do it? Well, you multiply the numbers using sign rules. What is the sign of the 3? Positive. The 5? Negative. When you multiply or divide with different signs, the answer is negative. So we multiply the numbers, and then you multiply the names, and you get a new name. And when you multiply with like bases, you add the exponents. That's an understood 1, so we get x to the 6th, y to the 5th. We multiply with like bases, y's with y's. We add the exponents, y to the 5th. When you multiply, you get a new name. When you add, the name stays the same. So compare that when you look at 7 and 8. On 7, our name stayed the same. On 8, we got a new name. Any questions so far? Number 9. You got it? All right. Number 9, this is on page 5 again, the rules. To divide, we use special rules, but we reduce the numbers. This is what it says on page 5. And reduce the names. And when you divide with like bases, you subtract the exponents. This is division. We know it's division because a fraction bar means divide. Now, just like we did numbers with number, and x with x, and y with y, because we have to do like bases when we multiply, we have to do like bases when we divide. So we do number with number, x with x's, y's with y's. When you divide with like bases, you subtract the exponents. So on the 35 and 30, to reduce it, what are we going to do? We want to reduce the numbers, right? What's the biggest thing that are going to 35 and 30? Greatest common factor. Here's how you do it. Let's go through that drill. Prime factorization. You don't have to show this on the test, no. But you need to know how to do it in case I give you a big, bad, ugly one that you have to do it on the test for. So we're going to do the prime factorization of each of them. We're going to write them out as the product of their primes. We do not write them exponentially for GCF. We just write them all out. Then what do? You find the common factors. There's a common 5 they both have. If there was more than one thing you circled, you'd multiply all of those. But there's only one, so your GCF is 5. So we're going to divide them both by 5. 35 divided by 5 is 7. 30 divided by 5 is 6. So we reduce the numbers. Now we reduce the names and get a new name. And when you divide with like bases, you subtract. Now this is a seventh. What we have, so you can see this, is x to the seventh over x to the third. When you divide with like bases, you subtract. What's the difference in 7 and 3? 4. Where were there more at, top or bottom? Top. So we need an x to the fourth on top. Now we're going to look at our y's, and I'll blow it up in case it's hard to see. What we have is y understood to be to the first over y to the fifth. When you divide with like bases, you subtract. What's the difference in the number of y's? 4. Where were there more at? So we put our y on the bottom. Yes.
On the bottom, we can make a space when we put that right beside the 6.
Right beside the 6. Just cram it together. Now I need to talk about something else right here. Y to the first divided by y to the fifth. That's what's going on. Is y to the 1 minus 5. What is y to the 1 minus 5? Y to the negative 4. So it's 7x to the fourth y to the negative 4. But the negative tells us to do something. The negative on the exponent, reciprocates it. You read this as the reciprocal. I made a mess out of that. The reciprocal of y to the fourth, which is 1 over y to the fourth. That's why I knitted up on bottom using exponential law. It's easier just to look at it and say we had more on the bottom, we put it on the bottom. But if you actually go through the process of subtracting the exponents, somebody's going to get a negative 4, and then you need to know what to do with it. You read it as the reciprocal of y to the fourth, which is 1 over y to the fourth, which means it ends up on the bottom. Any questions on number 9? Okay. Number 10. This probably don't need to be on the air, but on the last test, about 80 to 90% of all of my students missed that. And it's actually on page 5, and it's actually on the review, and who knows why you didn't know how to do it to start with, but a lot of people missed it. We had all kinds of stuff here. So let's talk about it. What does that little 2 mean? Square. And what does square mean? Times itself. So this means 0.05 times itself. So we're multiplying a decimal times a decimal. So what do? We just multiply. 5 times 5 is 25. And then here's the part people didn't remember. What do you do after that? You count up the number of decimal places in the... There's a word. We need our word. It's on the rules test. What is it? What do you call the things that you're multiplying together? When you reduce a fraction, you're looking for what will multiply into both. What'd you multiply by to get something? Factors. When you reduce, you divide by the greatest common factor. What's a factor? What you use to multiply to get it. We do the prime factorization. All the prime numbers that multiply. So we've talked about factorization, and we've talked about greatest common factor, and then we don't remember what a word factor is. But we need to know that word factor. You count up the number of decimal places in the factors, and you put that many decimal places in the, what's the name of the answer? Product. And you're going to need to know that. And then we put zeros as placeholders. And we have a decimal there. .0025. We need to know our terminology. You count up the number of decimal places in the what? Factors. What are factors? What you're using to multiply by. Prime factorization, 2 times 3 times 5 times 7 times whatever. Okay? Any questions on number 10? Okay? Number 11. Number 11 is .002 cubed. What does cube mean? Times itself. Now, it's not what times itself 3 times equal, it's times itself 3 times. So it's .002, negative .002 times itself, negative .002 times itself, negative 002. Now, don't write this down or do this, but I have students that do this. I have a bunch of students that when they multiply .002 times .002, they don't just put 4, they multiply through by the first 2, and they get that line, and then they multiply through by that 0 and get that line, and then they multiply through by this 0 and get this line, and then they add all that up, and all they had to do is keep the 4, because all the rest of it's zeros. You'd be amazed at how many students I have do that. There's no need in doing that. We're just going to go 2 times 2 is 4. We're going to take that answer 4 times 2 is 8. All right, we got that. And we don't need half a page of zeros, okay? Now, we want to check where our decimal goes. To check where our decimal goes, we count up the number of decimal places in the factors, so we should write it out so we don't mess up. 1, 2, 3, 4, 5, 6, 7, 8, 9. We put that many in the product. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's where our decimal goes. Fill it in with zeros. And then we check our signs. We had 3 negatives, and we're multiplying. So when you multiply with an odd number of negatives, good, the answer is negative. Don't forget to check your signs. What happens is people do all that decimal stuff, and then they forget to check their signs, right? I always double check my signs in high school. I'd have probably had 100 average in Algebra 2 if I had not made 2 or 3 sign rule mistakes somewhere, okay? So just a few little sign rule mistakes that get you, so I double check those signs. I got to double checking them so I wouldn't mess up, okay? All right, any questions on number 11? Number 12 gives people fits also. There's a lot of people that miss that one on the test. I let people use graphing calculators and they still miss it sometime. But I make you show your work, so we got bogged down in the work. Let's look at number 12. To divide by a decimal, you move the decimal over enough places in the divisor so that the divisor becomes a whole number. Got to get our terminology down. This is all on the rules test, and it's next week, right? To divide by a decimal, you move it over enough places in the divisor so the divisor becomes a whole number. Then you move it the same number of places in the dividend. And from there, you move it straight up into the quotient. And since there's a gap, we have to put a 0 as a placeholder. Yes, ma'am. If you spell divisor, D-I-V-I-D-E-N-D, I probably will. If you don't do that, I'll probably let it slide. Question was, do I count off for misspelled words? Not if you barely misspell them, no. But if you spell divisor, dividend, I'll probably count it wrong, yeah. Anyway. What somebody will do is they'll put D-I-V period, you know, and then on the next one they'll put D-I-V and they'll put a little something so it kind of looks like an I or an E and hope I'll take it. That's why I said that. You know how you do those true false ones? They look like that, you know. So. All right, we just had an announcement advertisement. That's why there's a little delay here. So here we go back to the deal. You move the decimal enough places in the divisor so that the divisor becomes a whole number. Move it the same number of places in the dividend straight up into the quotient. And then you divide as if they were whole numbers. So 12 won't go into 2, so we try 24. 12 goes into 24. 2. So we see how many times it'll go. 2. Then you multiply. 2 times 12 is 24. Then you subtract. And then you bring down, and then you start over. How many times will 12 go into 0? So we have to put a 0 as a placeholder, and then we bring down the next number, 1. So then we say how many times will 12 go into 1? 0. And that 0 is above the 1. And then we bring down the next number, 2. And then we say how many times will 12 go into 12? 1. And then we multiply. 1 times 12 is 12. And then you subtract. And then you bring down. How many times will 12 go into 0? 0. We made it to our decimal. So our answer is 20,010. Any questions on number 12? Divisor, dividend, quotient. All right. Number 13. Number 13 is a division sentence. We can divide or reduce the numbers, divide or reduce the names. We could rewrite this as a fraction because that division is really a fraction bar. If it helps you to write it as a fraction, then write it as a fraction. To reduce, we reduce the numbers, and then we reduce the names, and we divide with like bases, you subtract the exponents. When you divide radicals, what do? You just divide. So here we go. We divide our numbers. 28 divided by 7. 4. I'll get there in a second. Did I mess up? Okay. Y to the 5th divided by y to the 3rd. When we divide with like bases, we subtract, so the difference is 2, where were there more at? Top, see you later, but I'm going to keep teaching. And so we get x squared. The difference in the number of y's is 5. There's more on bottom. I messed up. I'll start over. Yes. Square root. Square root. So radicals are the square roots.